Hello, welcome back to the channel. So let's continue our previous videos and do one more question on the integrals of the form when you have a square plus minus b square terms in your integral calculations. But this time this is an even more interesting question because you see another pattern over here since you're calculating the definite integral which is based from minus a to a, where your a is pi by 12. We'll have to check for another property of this function in order to simplify our definite integral over here. You remember we discussed in the previous videos that whenever you are calculating the definite integrals from minus a to a of fx dx, if your function is an odd function, then your integral is 0. But if a function is an even function, then this integral would be simply twice of 0 to a and then the function expression, which would remain the same as fx dx, right? So if you have not watched my previous videos on those properties, I would highly suggest you to first watch those videos in order to get the full idea about this video over here. And those videos you can always find on the I button above. So now let's first write our function over here. Our function in this integral is basically 15x cubed upon x square plus 1 times 9 minus x square 5 by 2 over here, right? So let's, in order to check for odd and even function property, let's calculate the f of minus x in this case as well. So this would be 15 of minus x cube upon minus x whole square plus 1, 9 minus x whole square to the power 5 by 2 over here. And if we simplify this expression over here, we'll get minus 15x cube upon x square plus 1, 9 minus x square to the power 5 by 2. And if you'll clearly notice fx and f of minus x over here, you'll see that in this case, the only difference is the minus sign over here, right? Rest function is completely the same. So you see one interesting observation over here, that your fx is equal to minus of f of minus x, right? Which is the property of an odd function, right? So that is why, since this function, this fx is our odd function and we are calculating the integral, the definite integral from minus a to a of an odd function, this integral will simply be equal to 0 in this case. So that is why if you'll calculate the answer to this definite integral expression, you'll get 0 at the end of this definite integral. You can also check the answer if you want to by using trigonometric substitution over here, and you'll clearly notice that when you do trigonometric substitution in this case in order to calculate the definite integral, you'll get 0 at the end, because we know about the properties of odd functions that whenever we are calculating the definite integral from minus a to a of an odd function, it's always 0 in this case. So that was a very simple problem to solve if you knew the property of odd and even functions. So that's it for this video, and again the main takeaway from this video is whenever you see this pattern in your definite integral, that you're calculating the definite integral from minus a to a, you should definitely check for if your function is an odd function or an even function. Because if your function is an odd function or an even function and you're taking the definite integral from minus a to a, you can further simplify your integral expressions. Or maybe if your function is an odd function, you know that your integral in this case will be 0. So feel free to comment down in this video if you have any doubts. Follow the channel in order to get notified about the other videos that I'll be uploading. Stay tuned. Thank you so much for watching. Bye bye. Take care.